Okay. All right. So the worksheet we just went over, what type of compounds were those called? Somebody help me out. Binary ionic formulas. Very good. So binary ionic formulas contained two elements, correct? Side conversations need to stop, please. Thank you. All right. So what we're going to talk about today, if I can get this to work. Oh, look how old my hands look. Ugh. All right. Are ternary ionic compounds. What do you think ternary means in this situation? It's going to be three or more, actually. Okay? So ternary ionic compounds are compounds that generally contain three or more elements in the compound. There are still a couple of exceptions to that where they will only contain two elements, but there's special things about those. All right? Okay? They will always contain a polyatomic ion. Do you guys recall that from last semester? The polyatomic ions were groups of elements bonded together covalently, but still had an overall charge. Okay? All right, so ternary ionic compounds will always contain a polyatomic ion. Please make sure you're writing this stuff down so you'll have it to refer to when working on the problems. Okay? All right. Most of our polyatomic ions are negative and will contain or will end with the suffix ATE or ITE, which you should see on your polyatomic ion sheet. Here in a second, I will point out the ones that don't, so you can mark them. Okay? But there is one positive polyatomic ion that we will deal with, and that is ammonium, which is slightly different from ammonia, and it is NH4 with a +1 charge. I will guarantee at least one person in every class period on the test for this unit, which will be in a week and a half, 2 weeks, something like that, they will come up or they will raise their hand and say, I can't find ammonium on the periodic table. And I will tell them that's because it's not on the periodic table. And after they get done crying, I will point it out to them on their polyatomic ion sheet. Just kidding about the crying thing. All right. Ooh, God, I was recording. Okay. Just kidding about the crying. I don't promote crying in class. All right. Okay. Give you guys another minute or so to finish writing that down, and then we're going to look at our polyatomic ion sheets. We're going to mark some stuff. And guys, I am going to try and record each new thing we add, so you always have to go back to, or if you're like the person that's absent today, you would have a chance to look at it. All right? In fact, the assignment from Thursday is up now. Okay. Is everybody ready to look at the polyatomic ion sheet? Okay, so first of all, this is one that I typed up based on a couple other lists. Some chemistry teachers make you guys memorize like 10 of these. I do not. I would rather you guys have these. If you take the college class, there's about 10 of them you have to memorize for that. But we will use them so much between now and the end of the year that it really isn't much to memorize. You will already have them memorized. Like a lot of them you'll have memorized by the time we get on with this unit. Now, if you will look, this chart I typed up, I have organized it. First column are all -1. Second column is all -2. The last column we have the -3, a very small -4, and our only +1. Okay? Each column or each grouping is in alphabetical order. That helps you to find things. So if you're looking for something that starts with a T, you can go down to the T's real quick, okay? I will tell you, the -4 one, I don't think we'll ever use pyrophosphate. I just thought it sounded cool, so I stuck it on the list, because why not? All right, Now, of our other exceptions, if you look, the very second one is azide or azide. I don't know how you pronounce it correctly. It is weird in two ways. One, it ends in IDE. And two, it's a single element, but there's three of them bonded together, and the overall charge for the three is -1. Generally, if we had three ends, that would be -9, right? Because each one's -3. But it's a polyatomic ion. I believe that's used in a type of rocket fuel. All right? If you go down about 5 more, and what I would do, guys, is I would highlight these, circle them, star them, something to make them easier to find because they're going to be weird. And if you're sitting there trying to figure it out on a quiz, and then you see your highlight, you'll be like, oh yeah, that's a weird one. All right, going down a little bit more is cyanide. Cyanide is a polyatomic ion. It's also -1. It is a poison. Sadly, it's what we used to use in the death chamber at the Missouri Penitentiary. Huh? I have. We actually took a leadership group at one of the schools I was at. I don't know why. We were down there for a conference, and one of the tours they planned was that. I actually have a picture of the student council president and the vice president sitting in the chairs, because Missouri at the time was, well, and still, was the only state that ever had a double-seater death chamber. Why? I mean, that's just sad. It's sad because of so many reasons. All right. So anyway, so cyanide. If you go down about 4 more, hydroxide. We will use hydroxide a lot. Hydroxide is a very, very common thing. When you talk about acids and bases, the main or the original definition of a base was a compound that ionized in water and released hydroxide ions. Okay, so most of your bases have hydroxide in them. Okay, all right. And then if we go just over and down 1, so over the next column and down 1 is peroxide. Okay, and it is O2 with a -2 charge. Generally, O2 is neutral and is a gas, but in certain compounds, it forms this weird ion called peroxide. The most common one that you guys have probably heard of is hydrogen peroxide, used to clean cuts and stuff like that. There's that joke. 2 guys went into a restaurant. One said, I'll have H2O. The second one said, I'll have H2O too. The second one died. So, yeah, don't drink hydrogen peroxide. All right. And actually, you shouldn't overuse it on a cut. It will actually keep your cut from healing. It's good to clean it out, but if you keep putting it on there, it makes it heal slower. All right. Those are the ones that are a little different that you need to pay attention to. All right. Are you guys ready to do a couple examples? Oh, great. Oh, that's about it. Okay. Here we go. All right. The first example we're going to do is potassium sulfate. Are you with me? Okay. What is, first of all, the symbol for potassium? Okay. And what is its charge from your periodic table? Plus what? +1. Very good. All right. And then sulfate. Oh, it ends in AT. That tells me I need my other sheet. All right. Sulfate, I go down the first column, no S's. Go down in the second column, oh, selenate, silicate, sulfate. Go straight over. Do not go opposite a little bit. Make sure you go straight over. And it is SO4 with a -2 charge. SO4, -2. Okay? So what is the least common multiple of 2 and 1? 2. What's 2 divided by 1? 2. K2. What's 2 divided by 2? 1. So we only need 1 SO4, so we write it exactly like it is. We don't have to do anything else to it. As people knowledgeable in chemistry, which you guys are becoming, you will recognize going forward that, oh, SO4, that must be a polyatomic ion. I mean, that's just part of what it is. All right? Any questions on that part? That's just like we've been doing, except we got a little bit more. Again, capitalization matters. Make sure it doesn't look all funky like a S with a little tiny O for, that's not an element, it just would be wrong. All right, so make sure capitalization matters. Kind of like punctuation matters, right? Commas are important. The difference between let's eat grandma and let's eat grandma. Go ahead, record it. That's just a funny joke. All right. Okay. Now, sometimes the question arises, what if I need more than one of the polyatomic ions? Thank you. Yeah, what if you need more than one polyatomic ion? Well, if you need multiple polyatomic ions, you have to use parentheses. Okay? What do I mean by that? Well, let's take a look at one. Magnesium nitrate. Let's slide over this way. All right. All right, magnesium nitrate. What's the symbol for magnesium? Mg. All right. And what is the charge for magnesium? +2. What is this nitrate? Oh, we got to go to our pig sheet because it's got an ATE. We go down looking for N's. Oh, the very first N is nitrate. And it is NO3. And it is -1. You guys see that? All right. Again, least common multiple of 2 and 1. 2. What's 2 divided by 2?
1.
So just Mg. And then 2 divided by 1? 2. So NO3, 2. Now, if I just put it like that, what does it look like? It looks like 32, right? But we put parentheses around the NO3, like that. And that tells me I have 2 nitrates. Sometimes people go, well, can I just go N2O6? Nope. Because this gives me a little bit of a clue about the structure that I have 2 nitrates. N2O6 would be, I don't know, something else. All right, so it's got to be in parentheses, and it's got to be, the numbers have to be correct. If we were adding up the total atoms, yes, we have 2 nitrogens and 6 oxygens. But for this, we just do it this way. Now, what if I wasn't sure on the K2SO4, so I go ahead and put it in parentheses? Is that okay? No. It's like putting extra commas in a sentence or punctuation marks that you don't need. So, no, not okay. All right. What if I put them both in parentheses? No. Only parentheses around what you need when you need them. Right? We do this to use, the distributive property from algebra. Then we distribute it out. Does that make sense? All right. Let's do a couple more examples. Okay. What time do we get out? 1. Okay, so we got just enough time to do 2 quick examples. Let's go ammonium tartrate. Okay, ammonium. What's ammonium? Do you remember? It's NH4. That's our tricky one. NH4 with a +1. Tartrate. Again, it ends in ATE. We find it right here. I'm going to have somebody read it off because that's a lot. It is what?
C4 or H4.
Oh, C4. H4. O6?
Yeah.
Okay.
-2.
-2. All right. What do they both go into? 2. Okay? 2. So how many ammoniums do I need? 2. So I would do the NH4, put it in parentheses, and the 2 on the outside. And then how many tartrates do I need? 1. All right? So just C4H4O6. Okay? Have you guys ever used cream of tartar in cooking? That's actually tartaric acid, so it has this. I'll show you how to write acids later. All right? Okay, last one I'm going to do. This is what I talked about the other day. I heard this. I actually looked it up. It is actually true. Lithium citrate. All right. Lithium has an atomic mass of roughly 6.99. That's where the name of 7-Up came from. Lithium citrate is used to help treat depression. It is a mood enhancer. They used to put lithium citrate in 7-Up till like the 1950s. That's where the name came from. 7, the element 7, up made you feel happier. Isn't that crazy? All right, so lithium is Li. What's the charge for Li? Plus 1. Citrate. You find it? There it is. Yep, C6H5O7. And it's -3. Which do I need more of?
Lithium.
Lithium. How many lithiums do I need?
3.
3. Li3 C6H5O7. All right, makes sense? All right, very good. Let me stop the recording and then I will give you an update.